Hi, my name is Joel Hellemark, and I'm the founder and CEO of a company called Sana. At Sana, we're a team of researchers and engineers who have been working on applying machine learning on anything ranging from personalization of Google search to personalized recommendations at Spotify to a wide variety of tasks at Boston Consulting Group. And what we're passionate about is how we can bring the benefits of artificial intelligence to education. So how can we use artificial intelligence to improve learning outcomes and sort of augment teachers? So we develop a range of AI solutions for the education industry, which big publishers and education technology companies can integrate to improve their learning experiences and engagement with the services. So we've developed the system in a truly content-agnostic way, meaning that we could apply it truly to any educational domain. So we work with anything from Sweden's largest programming boot camp for programming to some of Sweden's largest publishers for teaching math to some of the world's largest language learning companies. So we've developed a solution that can scale across subjects and domain and languages. The current market size of AI applied to education is 537 million, and it's expected to grow to 6 billion by 2024. And we've repeatedly proven ourselves to be sort of the world-leading technology when it comes to AI applied to education. And our ambition is truly ubiquity. So if you're learning something online, whether it's corporate education, language learning, or programming, that user experience should be powered by the Sana technology. So we're really out for this market. What the key difference is, why this is possible now and why you couldn't do this 5 or 10 years ago, is that historically you've solved this to a large extent by heuristics and rules-based systems, meaning that humans had to sit and tag up the content, tell the difficulty of questions, tell how one item related to another item. However, the key differentiator is our ability to learn directly from raw data, meaning that in difference from historical approaches, which relied on human domain knowledge, we can learn those parameters directly by analyzing historical data. That means two things. One is that it's much quicker to integrate. So some of these systems historically could take 18 months to get to market. Our quickest integration with a partner was done in a single day. So this means that you can integrate it much quicker. In addition to that, the performance also is significantly higher because you can capture a much richer representation of how students learn. So how do we model how students learn? We essentially look at these parameters. So we look at the proficiency of a student, their assessment needs, their knowledge gaps. Then we look at strategies of how to teach the material. How much should it be repeated to increase engagement? And a range of other parameters. What should be the difficulty of content? Then we model the content as well. So we model the difficulty of the content, the instructional value of the content, assessment value of the content. And then when we combine these aspects, we get the optimal next recommendation for the student in real time. So historically, you might have signed up to Rosetta Stone or an online learning product and received the exact same content in the exact same way. Now with Sana, this gets uniquely personalized to you based on what you've already mastered, what worked best for similar student, and your knowledge gaps. And this could be implemented essentially in 2 API calls. So you make one request to our REST API, and then we post back the next optimal content that you should see next. And this is simply the full integration. So an education company that is looking to adopt AI could implement 2 API calls and have machine learning up and running. One example that we've worked with is Sweden's largest publisher for math. So what's really interesting is that Bill and Melinda Gates published a study where students that received personalized learning had 50% better learning outcomes in a year. So now we're very excited about bringing this to Sweden's schools with one of Sweden's largest publishers called NE. So NE is in 75% of Swedish schools, and we're excited about what Sana could do for them. In the user experience for NE, this is essentially a student that is learning math. So in real time, as they answer questions, we identify their knowledge gaps, their proficiency, what material they need to repeat to commit to long-term memory, and recommend the next explanation or question that this student should see in real time. So we quite recently participated in this global Duolingo benchmark, which is interesting for a wide variety of different reasons. One is that there hasn't really existed clear benchmarks to evaluate model performance, algorithm performance historically. So this was really a way in which we could prove the algorithm performance. And what's interesting, the other participants in that competitions were specialized in language modeling. Whereas in our team, we know very little about how we learn languages. However, we're very good at machine learning. And using machine learning, we were able to transcend the limits of traditional approaches that the professors at Cambridge and this Chinese company which specialized in language modeling had taken. And we ended up winning every single category on all evaluation metrics. So this shows the power of an approach that's content agnostic and can learn to model and work across all domains. So that's essentially Sana Labs, AI as a service for the education industry, which can be integrated in this. Thank you.